In this video, I want to use some basic math derivations and pseudocode to walk you through the strategic portfolio allocation approach of Markowitz. So the video is well suited for undergrad students and also for MBA students. So the portfolio selection process of Markowitz is a two-step approach. Now step one is we need to find the tangency portfolio. And step two is that based on the investor's risk aversion, we find the optimal portfolio on the capital allocation line. And remember, the capital allocation line is the linear connecting line between the tangency portfolio and the risk-free rate. So let's add some math intuition for step one. Now, I'm going to present three ways for determining the tangency portfolio. The first approach is the most direct one. You have to run a numerical optimization across all possible portfolio weights WP. And you're going to search for the portfolio weight that maximizes the portfolio's Sharpe ratio. The resulting optimal portfolio weight is then the tangency portfolio, which I denote as WTP. I also like the upcoming second approach, as it gives us not only the portfolio weights of the tangency portfolio, WTP, but it also gives us any other efficient portfolio allocation, WF. Now, that's the approach that is often used in financial software, which displays the efficient frontier. So here's what you would do numerically. So look at the mu-sigma diagram. You discretize the x-axis as fine as you like. That specifies the target risk, sigma p, for which you are now going to find the unique portfolio that offers for that risk the highest expected return mu-p. Notice, capital sigma is an exogenous data input. It's the covariance matrix of asset returns. The last constraint is called the full investment constraint. This says that all the wealth needs to be invested into the risky assets. As you have a grid for sigma p, and hence also for sigma square p, you can now solve the previous optimization problem for any target risk. Mathematically, it means that for all target risks, sigma square p, within a lower bound and an upper bound, you're going to solve the previous optimization problem. And here LB denotes the lower bound, UB denotes the upper bound, and increment is the step size of the grid. Note, the resulting efficient portfolios WF are all on the efficient frontier. In order to plot the efficient frontier, you have to record their respective expected return, μf, and their respective variance, sigma square f. Now you're going to find the tangency portfolio as the efficient portfolio with the highest Sharpe ratio. Now the upcoming third approach for getting the tangency portfolio is to calculate the full minimum variance frontier. The upper part of that frontier is the efficient frontier. The lower part is the inefficient frontier. Similar to the previous approach, you find the tangency portfolio as the efficient portfolio with the highest Sharpe ratio. So mathematically, you do create a grid for all expected portfolio returns that you want to consider. We call them mu-p. And for these, you set a lower bound, an upper bound, and an incremental step size. And now you're looking for a portfolio of risky assets that earns the target expected return μp and that exposes the investor to the least amount of risk. Note here that the tangency portfolio will be the efficient portfolio with the highest Sharpe ratio. Okay, let's pause for a minute. We just talked about 3 ways to determine the tangency portfolio. Once you have its portfolio weights, WTP, you determine its expected return, its volatility, and its Sharpe ratio. So let's move on to the second step of the Markowitz portfolio selection procedure. Given the tangency portfolio, and importantly, given the investor's risk aversion, we find now how much to lever the tangency portfolio up or down. So investor I has mean variance preferences with a risk aversion gamma I, which is 0 or larger than 0. The mean variance investor seeks to find the optimal fraction of wealth, yi, that should be invested into the tangency portfolio, and the share 1 minus yi that should be invested into the risk-free instrument. So if we connect back to the case where we are looking for the optimal portfolio for each of the 200,000 employees of Daimler, we would solve the following problem. The first order condition would look as follows. We set that to 0, and then we solve for the optimal fraction of wealth that employee I invests into the tangency portfolio. And finally, the optimal allocation for employee I would be to invest yi star into the tangency portfolio and 1 minus yi star into the risk-free asset. Now it's likely that some of the 280,000 Daimler employees, if not all of them, will have difficulties to state their coefficient of risk aversion. So alternatively, they could state the maximum volatility that they are willing to accept. For example, let's say Pauline wants her optimal portfolio to have an annualized volatility of 20%. Also assume that the tangency portfolio has an expected volatility of 15%. And assume in addition that Pauline wants to invest 100,000 euros. Now you therefore know that y square times the variance of the TP portfolio needs to be equal to the variance that Pauline is willing to take. Now you solve for y star, and you see it just coincides with the ratio of the volatility that Pauline wants to hold in her portfolio divided by the volatility of the tangency portfolio. Plugging in the numbers, in that example you have 0.2 divided by 0.15, which gives you 1.333. So that solution would say that as Pauline is willing to be exposed to 20% of systematic volatility, while the TP portfolio is exposed to 15% volatility, the optimal portfolio for Pauline would be to borrow an additional 33,333 euros at the risk-free rate and to invest a total of 133,333 euros into the tangency portfolio. Notice, Pauline's optimal portfolio will only have exposure to systematic risk, Systematic risk is also called undiversifiable risk. And here is why. WTP has 100% exposure to systematic risk. The ratio sigma CP over sigma TP quantifies the optimal amount of leverage that is going to be applied to the systematic risk of the TP portfolio. So Pauline and any other employee of Daimler will therefore not be exposed to any type of asset-specific risk.
Got feedback? We would love to hear it. Please drop us a line. And if you liked the video, give it a thumbs up. And don't forget to subscribe to the channel.